Hello friends, I'm Shravishri. Welcome back to my channel Easy Physics. Today our topic is about measurements. What is a measurement? Measurement is a process of detecting an unknown physical quantity by using standard quantities. For example, take a book, okay? Take a book and use a scale to find its length. Suppose the length was 20 centimeters. What did you do? You underwent through a process called measurement where the unknown physical quantity here was the length of that book. The scale was a standard quantity. 20 was the magnitude and centimeter was the unit of book length. Okay. So we use measurements in everyday life to measure mass, to measure volume, to measure length, to measure temperature and etc. Now here is what is the importance of measurement in physics. In physics, to understand any phenomena, we know we need to do experiments. We perform experiments and experiments require measurements. And we measure several physical properties like length, mass, time, temperature, pressure, etc. Okay, so that is the importance of measurement in physics. Now our topic is what is a physical quantity? Simply, physical quantities or physical properties should be measurable and they should be described by a number. For example, if we take quantities like love, beauty, goodness, they are not measurable. We can say that kid is very beautiful, he is very beautiful. But can we measure the beautiness? Of course not. So physical quantities are the quantities that can be measured and described by a number. Example, mass. Mass of a person is 65 kilograms. Length of a table is 3 meters. We can measure. Area of the hall is 100 square meters. Temperature of a room is 300 kelvins. Now, types of physical quantities. First one is fundamental quantities. Okay, fundamental quantities are the physical quantities which do not depend on any other physical quantity for their measurement. These are called as fundamental quantities. Example, mass. The units of mass are grams, kilograms. Okay, length. Units of length may be meters, kilometers, centimeters, feet, time and temperature. These are fundamental quantities. Okay, second one is derived quantities. These are the quantities which depend on one or more fundamental quantities for their measurement. Example, area, volume, speed and force. What are the units for area? Meter square. Definitely meter into meter makes meter square. This is not a fundamental quantity. We require two fundamental quantities to describe area. For example, volume. Meter cube. Okay, units of volume, meter cube. Meter, meter, meter. We require three physical quantities here. Now coming to units for a measurement. Okay, we know what is a unit. Unit is the standard used for the measurement of physical quantity. It is a standard used for the measurement of any physical quantity. Example, meter, feet, inch for length, kilogram, pound for mass and etc. So there are many characteristics of units. Units should be well defined and they should be of suitable size. They should be invariable, indestructible and internationally acceptable. So there are many systems of units. First one is CGS system of unit. Okay, CGS stands for centimeter, gram and second. These are the fundamental units of length, mass and time. Centimeter is a unit for length, gram is a unit for mass and S, seconds, is a unit for time. Second system of units is MKS system of unit. Okay, meter here stands, M stands for meter, K stands for kilogram and S stands for second. Third system of units are FPS system of units. Okay, this system was introduced in Britain. Okay, F stands for foot, P stands for pound, and S stands for second. These are again fundamental units of length, mass, and time. Now coming to International System of Units, SI systems, we call them as System of International Units. Okay, System of International Units consists of 7 fundamental units and 2 supplementary units. Let's see what are they. 7 fundamental units are length. These are fundamental quantities I mentioned here: length, mass, time, temperature, electric current, luminous intensity, and amount of substance. Meter is the unit for length in SI units, and symbol we represent with small m. Mass is a unit for kilogram, we represent with kg. Time is a unit for time, we use second is a unit for time. And we use Kelvin for temperature, ampere for electric current, candela for luminous intensity, and mole for amount of substance. These are all SI units, and I have given symbols here, please go through them. Now coming to meter. We always use meter. The length of this room is 20 meters. Okay, the height of a person is some 5 point some meters, but we do not know exactly what is a meter, how it is defined. Meter is the length of the path travelled by a light in a vacuum during a time interval of 1 by 2997 lakhs 92,458 of a second. It is the proper definition of a meter. I have given the definition of kilogram here. Please go through it. It is the internationally accepted definition for kilogram. Kilogram is the mass of a prototype cylinder of platinum iridium alloy preserved at the International Bureau of Weights and Measures at Servers near Paris. Okay, so this is the prototype cylinder of a platinum iridium alloy. Now coming to definition of second. 1 second is the time taken by 919 crores 26 lakhs 31,770 oscillations of the light emitted by a cesium-133 atom. This is the basic definition of a second. And I already told you there are 2 supplementary units. First one is radian. Okay, generally we use radian for 2D drawings. Okay, 2D circles. It is a unit it is a unit used to measure plane angle. Okay, plane is 2-dimensional. Plane angle we represent with 1 radian or some. Okay, radian is the unit for plane angles. And steradian. Steradian is used to measure solid angle. Okay, what is the difference between plane and steradian? Okay, radian and steradian, plane angle and solid angle. Solid angles are 3-dimensional. Okay, there is a difference between triangle, okay, triangle and a cone, right? Cone is a solid structure, it is a 3-dimensional, whereas triangle is a 2-dimensional. Okay, we use radian for 2-dimensional or plane angles and steradian for 3-dimensional solid angles. Okay, so we have here are the rules to write SI units. Full name of unit always starts with small letter. Okay, it should always start with small letter, not Newton. N should be small letter always. And second rule is symbol for unit is named after a scientist should be in capital letter. Okay, if the name of that unit is named after a scientist name, then it should be with capital letter. Third rule is they are all written in small letters. Symbols for other units, except the units which are named after the name of scientist, other symbols other than those names, they should be written in small letters. Next, fourth rule is one space. One space is left between the last digit of numerical and the symbol of a unit. If it is 10 kilograms, there should be one space left between 10 and kilograms. And fifth rule is units do not have plural forms. Generally people write 6 meters. We say 6 meters. Generally we should not say that. 6 meter is right. And sixth rule is there should not be any full stop. Seventh rule, no space is used between the symbols for units. Okay, there should not be any space. Okay, so seventh rule is no space is used between symbol for units. Okay, this is our first class about units and measurements. We'll continue our next topics of units and measurements in other classes. So if you students, if you like my video, please like, share, comment and subscribe to my channel. If you have any doubts, please post your doubts in the comment section. Thank you.